Hello folks, as promised we are going to work another problem right here. So in this problem we have our small plane being flown by someone, and our pilot, her destination is 200 is some distance due north of her. So she aims her plane, points it due north, or at least as far as the compass is concerned, and she's flying at a speed of 200 kilometers an hour. Okay. After 30 minutes, it finds out, according to her GPS, we'll say, it turns out she's actually only 90 kilometers from where she started. And also, her path is off. It wasn't straight north. It was slightly east of north. So the reason this happens is because the wind kind of got in the way. That happens. Makes sense. Our question is, how fast is the wind blowing and in what direction? So the speed and direction of the wind, i.e. we're looking for the wind velocity vector. Alrighty. Well, let's draw a picture again of what's going on. So the plane, suppose, starts here. So I'll say start here. And they wanted to go north. So straight north would be just, we'll go straight this way right here. Okay. Since this detail right here is given in the distance, I'm going to use the distance vector. So I'm going to call this vector A. And I'm going to say let A equal the intended displacement vector. Displacement vector. Okay. This is where she was supposed to end up. Okay. I'm going to create another one, B. I'll do that in blue. Oops. Sorry, it's a little thick. We'll call this the actual displacement vector. Okay, so she goes 7 degrees east of north. So that's a little funky. All that means is if you're looking straight north, you would go towards the east direction, which is to the left. To the right, and then 7 degrees. So I'm going to exaggerate it because 7 degrees is a very small angle. But this angle right here, I know, again, not to scale, obviously. This angle right here is 7 degrees. And I'll call that B. And so we know that the magnitude of B is 90 kilometers. And also the magnitude of A, which I forgot to write here, is 100 kilometers. Again, 100 because she was only flying for half an hour. Okay, so 200 kilometers in 1 hour, or 100 kilometer in half an hour. Okay, so if she was supposed to end up here, how did she end up over here? Well, it turns out that this vector that I just drew, I'll draw in green, that is the wind vector pushing her. Okay, pushing her plane, I suppose. So I'm going to call this W, and this W, I'm going to be careful here, W is going to represent not the speed of the wind exactly, but that's how far the wind pushed her. So I'm going to say the wind, like how far the wind pushed her. Wow, I spelled displacement wrong. Placement. I'm going to say wind displacement vector. Okay. Now we can figure out what we're going to do is we're going to figure out, okay, the wind pushed her some amount. And again, that means it pushed her that amount of distance in a certain amount of time, and we can do distance over time to find the magnitude. To find the speed. Alrighty? So that's our strategy here. The question is, I need to figure out the wind vector first, its direction. Okay, so the question is, well, how do I get there? Well, notice the way we've drawn it is that the resultant vector, B, is actually equal to having gone along A and then getting pushed by the wind, i.e. getting pushed by the wind vector. Okay, so we can actually figure this out now, and we could get the wind vector just because we already know what B and A are. So let's do that. Okay, so I know that the wind vector is equal to simply, I'll just subtract A from both sides, and I'll say B minus A. Oops, sorry, I don't know why I drew that one as an arrow. That should be just a subtraction sign. Okay, so what is B? Well, we can write the components of B, but we just need to be very, very careful about our kind of point of reference. Okay, so again, if I put this on a coordinate plane here, right here, oh, I accidentally pulled out a pencil, but that's okay. Here. So A, well, we'll start with A because A is going to be a little bit easier. A, remember the components of A are, well, 0 in the x direction and 100 in the vertical direction. B is going to be a little bit harder. Okay, so actually, let me color code this. I apologize. B. Okie doke. I just changed the colors there. B is going to be a little bit more tricky, but we can handle it. Well, if that's 7 degrees, I know that this angle right here, which was in blue, is 83 degrees. And so I can get the x and y component, just like we did in the koala problem. Okay? So the x component, I'll call it b sub x. Oops. B sub x, comma, b sub y. Excuse me. So again, bx is just going to be equal to 90, the length of the hypotenuse, times cosine of the angle. So cosine of 83 degrees, excuse me. And by is going to be 90 sine of 83 degrees. Okay. Sorry, this should be a minus sign right here. I apologize. Okay, so we can actually just run this calculation right now, and I'm going to just write it all out and then calculate it at the end. So again, our wind vector here is going to be equal to, again, so when we're subtracting vectors, we just subtract their components, the corresponding components. So our wind vector is going to be 90 cosine of 83 degrees. That's its horizontal component, and that's its horizontal, and its vertical component is going to be 90 sine of 83 degrees minus 100. Now just note it should be negative because the wind is pushing it southward, pushing the plane south. Okay. Okay. So let's actually calculate this. This ends up being, alrighty. So I threw it into my calculator, and I got this for my values. And again, it seems weird, but remember my picture is definitely exaggerated. We didn't get pushed actually that far because, again, 70 degrees in actuality is like that much. Okay. But anyway, so that's how far the plane was pushed again. So what we can say is that if I was to, again, draw this picture out, this distance right here is about 10.97, so about 11 kilometers, and then this distance from here to here is about, again, 10.7 kilometers. Okay. Alrighty. So remember that what this is a distance vector, and so what we want to find out is how far was the plane pushed in that half hour, in 30 minutes. That is, we're going to use this to calculate that. So what we're really looking for is the magnitude of W. And so we'll do that by calculating the square root of 10.97 squared plus 10.67 squared. I guess it should be negative 10.76, right? 10.67, but it's going to get squared anyway, so it doesn't matter. 10.97 squared, 10.67 squared, and we're going to take the square root of that, and that ends up being 15.30 kilometers. And so we're almost there. So what does this mean? In half an hour, the plane has been pushed 15.3 kilometers. And so we need to just take that 15.3 kilometers. Oops. 15.3 kilometers divided by half an hour, so 0.5 hours to get kilometers per hour, which is essentially doubling it. So that just means the wind blows at a speed of 30.60 kilometers per hour. I don't know why it's kmh. It should be km over h, I suppose, but that. Okay. Last little bit here is if we want to be specific about the direction, because when you're asking about, you know, the speed and the direction, often it just is easier to describe it using an angle. So I'll draw our wind vector right here. So our wind vector points like this, and you can tell it's roughly 45 degrees, somewhere around there. Although it's going to be slightly less because it does go like this. So again, our wind vector, I could use the speed or I could use the direction vector, but remember, they point in the same direction because the plane gets pushed in the direction that the wind is blowing. So it's the same. Again, this is the x component, which is 10.97. This is the vertical component, which is negative 10.67. And so I can use inverse tangent to actually get this angle. So I'm going to use inverse tangent of negative 10.67 over 10.97 to get, stand by, negative 44.21 degrees. When we're talking about directions, we often want this angle right here, call it phi, I suppose. So that'll be just the complement of that. Oops. So that ends up being 45.79 degrees, okay? So we can say that the wind blows at a speed of, wait, sorry, start that over. The wind blows, I'll say, 45.79 degrees east of south. Because for some reason, I don't know too much about navigation, but apparently you reference either north or south first, and then you say this much pointing to the east direction or west, etc. So we go 45.79 degrees east of south at a speed of 30.6 kilometers per hour. Whew. That one was a doozy, but hopefully it makes sense now that we've worked it out together, and thanks for watching. Stay spicy, folks.